Hey everyone, welcome to solving quadratics using square roots. So we're going to take the square roots and radicals practice that we had in the last lesson and start to apply it to our solving for quadratic functions. So now you'll use the skills. We'll take a look at quadratic functions that are in the form a times x squared plus c equals 0. So there's two main steps to doing this. First, we isolate the x squared term to obtain something like x squared equals c, where there's a constant on the right side. And then we solve for x by taking the square root. There's three scenarios that can happen here. So number one, if c, the constant, is greater than 0, then we take the x squared of it. We have a positive and negative root of c. If c is equal to 0 and we take the square root of it, then there's only one solution for x, and it is x equals 0. And if c is less than 0, then we have no real solutions because c would be negative, and we can't take the square root of a negative. Now, we might be looking at this, and what does this mean? Well, remember that a positive product can happen even if you multiply two negatives or two positives. So if I'm looking for something like the square root of 4, well, this 4 under the square root sign could have come from multiplying positive 2 times positive 2, but it could just as likely have been derived from multiplying negative 2 times negative 2. And so when we take the square root of something like that, we want to make sure that we use this plus minus sign, because it could have come from the square root of 4 could be two negatives or two positives. So we have plus or minus 2. Let's take a look at some examples. So we have 3x squared minus 27. We'll go ahead and move that negative 27 over because we want to isolate x squared. So we'll have 3x squared is equal to a positive 27. We'll divide through by 3, and we'll have x squared equals, I forget my squared, equals 9. Now we take the square root of both sides, and we get x equals, remember we have to include positive and negative 3. So this function has two intercepts, and they occur at positive and negative 3. 2x intercepts. Those are solutions. Now let's take a look at this example. X squared minus 10 equals negative 10. I'll move the negative 10 over to the right, and it becomes positive 10. So really, I have x squared is equal to 0. So then I take the square root of x squared, and I can also take the square root of 0. Taking the square root of 0 is okay. What happens is you'll get x equals 0. So we only have one solution, and it's 0. So this means that if you were to look at a parabola, you would have the parabola touch the x-axis at 0, and it would only touch once. Let's take a look at this example. I have negative 5x squared plus 11 equals 16. I want to move this over, this positive 11 over to the other side. I will have negative 5x squared equals, that 11 became negative, and so what I end up here is 5. If I go through and I divide by negative 5, it changes signs, so we have x squared equals negative 1. Well, you can go ahead and try it if you want to, but you can't take the square root of a negative number. So this is not allowed. So here we have no real solutions. Basically, what that means is that on a graph, you have a parabola that doesn't touch the x-axis at all. Something like that. All right, so here's a different example. We have x minus 1 all squared equals 25. And in this case, we want to square root first, right? We have to undo the squared sign here. So I take the square root of all of it, and I take the square root of the 25 on the right side. So on the left, it clears out that squared, and I'm left with x minus 1. On the right side, the square root of 25 is plus or minus 5. Then I move the negative 1 over, and I get x is equal to positive 1 plus or minus 5. Now, in this case, we have to split it up, and we have two possible solutions. We could have x equals 1 plus 5, in which case x equals 6. Or we could also have x equals 1 minus 5. In this case, x equals negative 4. So there are two solutions that satisfy the original equation. So when solving quadratic equations without even roots, apply the properties of radicals to simplify. So going back to what we had before. So we have 4x squared minus 13 equals 15. Let's go ahead and move over that negative 13 and becomes positive. So I have 4x squared is equal to 28. If I divide through by 4, I will get x squared equals 12. And then I take the square root of both sides. So x is going to be equal to plus or minus. And let's go ahead and split that 12 up into a perfect square number of 4 and 3. So in this case, x equals plus or minus square root of 4 is 2, but that 3 has to stay under the radical sign. So here we have to apply the rules, the product property of radicals, square roots. So in this example, again, we'll move that negative 13 over. We'll get x squared is equal to 32, I believe. If we take the square root of both sides, we'll have x on the left. We'll have plus or minus 32 will split into 16 and 2. And I can take the square root of 16, so x is equal to plus or minus 4 times the root of 2. So we need those properties of square roots in order to simplify for these examples. Now I want to switch up a little bit and take a look at applications of real quadratic problems. So a touch tank has a height of 3 feet. Its length is 3 times its width, and the volume of the tank is 270 cubic feet. Find the length and width of the tank. So let's take a look at some of the information. It has a height of 3 feet, and it has a length that we don't know, call it L. And then it has a width, let's try and label it over here. I'll call that W. All right, so we're going to have a let statement since we're talking about a word problem. So we'll let L represent the length, and we're going to let W represent the width. And we're talking about volume. So let's start with our volume formula for a rectangular cube. Volume is equal to length times width times height. The volume is also given to be 270 cubic feet. So if I replace this, I'll have 270 equals the length, which is unknown, times the width, which is unknown, but we do know the height is 3. So we can work with this one equation, but we have 2 unknowns, so we need to come up with another equation, and that comes from the sentence right here. The length is 3 times the width. So I'll have L is equal to 3 times the width. Let's call that equation 2. So how would you solve this? I would go ahead and use substitution, and I would sub 2 into 1. And I will simplify. I get 270 equals, the L is 3W times W times 3. Tidying things up, 270 equals 9W squared. Let's go ahead and divide through by 9. And I'll have W squared is equal to 270 divided by 9 is 30. And we have to take the square root of both sides. So W is going to be equal to plus or minus the square root of 30. We can't divide 30 up into any other perfect square numbers. So now that is my width, but let's consider the options here. We have the width that could be negative root 3 and the other width that could be positive root 3. And since we're talking about a real life situation with a touch tank, we can't have a negative width. So really all we're going to work with is the positive root 30 as the width. So we're going to go ahead and sub that back into, let me go this way, the length was equal to 3 times the width. So the length is equal to 3 times root 30. So there you go. We have the length and we have the width. Let's take a look at a different example. So the area of an equilateral triangle with side S is given by a formula. A is equal to the root of 3 divided by 4 times S squared. Solve for the side length of this traffic sign if it has an area of 390 root 3. So we're looking for the side length. We have an area that is equal to root 3 over 4 times S. We'll pull that out. A is equal to the root 3 over 4 times S squared. But the area is also equal to 390 times the root of 3. So with elimination, basically, we have square root of 3 over 4 times S squared is equal to 390 times the square root of 3. We can go ahead and start to simplify. Let's multiply by 4. Remember, we are trying to solve for S. The 4's cancel here, and I'll have the square root of 3 times S squared is equal to 1,560 times the square root of 3. I'll divide the square root of 3 on the left, which means I divide the square root of 3 on the right, so those cancel. And I have S squared is equal to 1,560. So to solve, I get the square root of both sides. S is equal to plus or minus square root of 160. I separated that into 4 and 390. I couldn't find another perfect square number that can be divided into 390. So S is equal to plus or minus 2 times the root of 390. But again, we're talking about a stop sign, so we cannot have a negative side. And so the only answer here is S equals 2 root 390. It's got to be the positive case. Great, so we're done with that lesson, and we're going to move on to solving quadratics using some other methods. So I'll see you soon.